Next, I'm just going to run through some examples. So we want, on this first problem, we want everything with y to be on the left side, everything with x to be on the right side. So I need to move the dx and I need to move the y squared. So if I divide both sides by y squared, I'm going to write it as 1 over y squared dy equals negative 4x dx. Now we know we're going to have to take the antiderivative, so I want to rewrite that 1 over y squared so that it's y to the negative 2 instead. We integrate both sides, so adding that integrand symbol is just showing that we're taking the antiderivative. Antiderivative of y to the negative 2 is negative y to the negative 1. Antiderivative of negative 4x is negative 2x squared plus c. So my goal is to get the y isolated. So the negative y to the negative 1, that's the same as negative 1 over y. And I just want it to be in the form y equals instead of negative 1 over y equals. So I would just first multiply both sides by y, and then divide by the negative 2x squared plus c. And that's it. On the second problem, again, we want y on the left side, x is on the right side. We do need to be careful with addition and subtraction. First, I'm going to move this x squared y over to the right, the whole thing, just by subtracting it. And now it feels a little bit more like the first problem. I need to clear the y by dividing by y, and I'm just going to write a 1 over y. And I'm going to move the dx over to the right side. This time, because 1 over y is special, I'm not going to write it as y to the negative 1 because I know it's just going to be ln y. So I have ln y equals the antiderivative of negative x squared is negative 1/3 x cubed plus c. A lot of these problems involving ln and e and things like that, to isolate the y, so to get rid of the natural log, it would look like this. So e undoes ln and ln undoes e. So I'm going to have it y equals e to this whole thing. This whole thing now becomes the exponent, 1/3 x cubed plus c. And that's it. So to isolate y when it's in ln, we use e and everything becomes the exponent. On our next problem, so I'm going to have dy dx equals 6xy squared. So hopefully we're getting the hang of this a little bit. I'm going to have 1 over y squared dy equals 6x dx. That y squared, I'm going to write it as y to the negative 2. And we integrate. The antiderivative of y to the negative 2 is negative y to the negative 1. The antiderivative of 6x is 3x squared plus c. This is just like the first problem. I'm going to have negative 1 over y equals 3x squared plus c, which means I'm going to have negative 1 over 3x squared plus c equals y. Okay, last one from this problem set. Negative dy dx equals negative 3x squared y. So I'm going to have, I can just divide both sides by a negative 1, make it a little bit nicer. So now I have 1 over y dy equals 3x squared dx. And we find the antiderivative. The 1 over y, we already know that's going to be ln. Ln y equals x cubed plus c. And just like before, to isolate the y when we have ln, I'm just going to have e. So it really kind of looks like this, where we make everything an exponent for e on both sides. The e and the natural log undo each other, leaving us just with y. And this, I'm just going to rewrite it so it looks a little bit cleaner. So y equals e to the x cubed plus c would be my final answer.